Hey guys. So I was thinking with myself today, and it's always good to remind yourself what you learned ages ago. And one of the basic that I deal with every day is the type of walls that we have in our projects. We have basically 4 types. Some engineers will classify them differently, but daily, the rule of thumb that I use are these 4. And doesn't mean if one wall is one type, doesn't mean that she's not another type. They're not exclusive. Okay. So for instance, the exterior walls, it's basically all the exterior walls on the name that are closing the building itself, where it's gonna have later a siding and a AVB somehow that will protect against the exterior moisture, is the protection against moisture, vapor, and stuff. And yeah, so the exterior walls is gonna have that extra layer of protection. But to accept the siding in the AVB, they need a sheeting, right? Which is it can be zip, it can be OSB, it can be plywood, whatever. But it has that protection for sound, for fire, and to make a surface to receive these layers of protection, siding, exterior finish, in the AVB, right? So that's the exterior wall. But all the exterior wall, they're also bearing wall, which is another classification. Bearing walls are walls that resist loads, design loads. It's not like the accessory blocking, accessory cabinets, the drywall, not that kind of load per se, but it's seismic loads, wind loads, the people walking around, everything. So that the heavy chunk of load, the bearing wall will resist. So the exterior wall is also classified as a bearing wall, okay? But we usually say exterior wall. If you say exterior bearing wall, it's kind of redundant, you know? Just say exterior wall. Good. But some sections of the exterior wall can be called shear walls. Why shear walls? So the engineer, he designs the building in certain sections of the wall. I would say not a lot on the exterior side. It has more shear walls on the interior side, as we are gonna go over just a little bit. But the exterior side has small portions of shear walls. It's strategically designed to receive loads on multiple directions. So let's say if the building is a rectangle and there's more wind come on a certain angle, on a certain facade, and the building needs to resist that wind, they're gonna put the strategic shear walls in some places. Okay, but what differs the shear wall than a bearing wall on the exterior side? It's probably gonna have on the plans, structural plans, a shear wall schedule, okay, and it's gonna different how you do the anchorage of that wall, the particular section. It can be a hold down, it can be a strap, but the other walls that are not shear walls not gonna have that. The nailing pattern is different. Okay, you should have more, usually more nails, you know, or even longer nails or more diameter on the nails to resist those loads, right? It also has more requirements for posts on each end. It also changes how you attach them vertically, because you have to attach them to the ground. It's concrete, it's wood. They require more, less space, more robust connections. So those particular sections, they're gonna be more required structurally speaking. Okay, so you can classify the exterior walls, but subcategories are exterior non-shear walls, because they don't have, they have the standard requirements for nailing pattern, posts, and everything, and how you attach them vertically and horizontally. But those exterior shear walls, they're gonna have more requirements, but it's not a lot in terms of linear footage. Okay, I'm not gonna guess saying a percentage, because it varies from projects to projects, engineers, so on. So going to the interior side, you also have bearing walls and shear walls. So in our daily wood framing projects, you can basically say both are bearing walls, they resist loads, but if you don't have a sheeting, wood sheeting, it's a bearing wall. If it has a sheeting, it's a shear wall. Okay, or you can basically say interior bearing shear wall or interior bearing non-shear wall. Be the same, but the same requirements from the exterior that I just explained goes to the interior. Okay, so more anchorage, posts, nailing pattern requirements. Like I said, this is just in our world of wood frame. Okay, but the bearing walls, for instance, they're gonna, like all walls, they're gonna have drywall on them, and that helps with the shear, because the shear wall is supposed to resist the loads, shear loads. So the wall is straight. It's straight. It doesn't go this way, you know, when there's a force. But anyways, the plywood and the OSB provides more shear capacity than drywall, but the drywall also provides shear. Okay, so these walls, they're supposed to hold the building going like this, you know. So yeah, and then after you do this analysis, all the other walls, assuming the building has no framing, no metal framing, the walls that are left out, usually the walls that are not in the structural plans are the partitions or non-load bearing walls. There's a NLB, stands for non-load bearing walls. The name already suggests it doesn't receive a lot of loads, but of course it's going to resist the weight itself. It's going to resist the weight of the drywall, you know, but it doesn't mean the load that comes from the floor system is not going to go through those partitions. Okay, and of course they have way less requirements. They're not gonna have sheeting on them for structural reasons. They don't require a lot of blockings. the headers, you don't need a lot of reinforcement for those type of walls. So that's the way I see it. So when I start analyzing, I'll go from the exterior. Exterior is easy, but for the interior, there's a lot of walls. You go to the structure and just compare these, what I just explained, and by elimination, you check and cross-check with the architectural, the walls that are left are non-load bearing walls. Okay. So yeah. Until next time, guys.